Question 7a. Use the information in the figure below to find the value of s. This is the given figure or diagram. To find the value of s, we need to add other angles such as a, b, and y. From this figure, once we get b, b is equal to s, alternate angles, since AC is parallel to this side. So let us see what happens next. From the figure, y is equal to 83 degrees, corresponding angles. Now that y is known, you can get b by considering triangle ACD. If you add the three angles in that triangle, the sum is 180 degrees. If you replace y with 3 degrees, you have this result, and b plus 130 equal to 180 degrees. If you make b to stand alone, you have 180 degrees minus 130 degrees, and that is 50 degrees. It follows that s is equal to b, and that is 50 degrees. Alternate angles. Alternatively, you can as well get a first. For you to get a, this line AB is parallel to DC. That means angle A is equal to 47. Alternate angles. Now let's get B. You add the three angles on this line, the sum is 180 degrees. You replace A with 47 degrees plus the rest angles equal to 180 degrees. That simplifies to this. If you make B the subject, you have 180 degrees minus 130 degrees, and that is 50 degrees. Therefore, S is equal to B equal to 50 degrees. Alternate angles. Question 7b. A boat sails 6 kilometers on a bearing of 040 degrees and then 8 kilometers on a bearing of 100 degrees. Roman figure 1. How far is the boat from its starting point? Roman figure 2. Calculate the bearing of the boat from its starting point. Leave your answers to the nearest kilometer and degree. Solution. This diagram illustrates the information. This is the starting point. The boat sails 6 kilometers on a bearing of 040 degrees to this point, that is point A. When the boat gets to point A, it moves again on a bearing of 100 degree from the north. Here is 100 degree, a distance of 8 kilometers to point B. Now, if here is 40 degrees, here is also 40 degrees. Alternate angles. The whole of this side is 180 degrees. If from here to here is 100, the remaining part is 80 degrees. So this angle becomes 40 degrees plus 80 degrees. That is 120 degrees. Now you are asked to find how far is the boat from the starting point. The boat is currently here. This is the starting point. You are asked to find this distance. because the side you are looking for, the angle facing it is known, you can use cosine rule because the two other sides are known as well. Roman figure 1, the distance of the boat from the starting point is BS, denoted by A. Cosine rule is applicable. This is the rule stated. You replace B and S with what they stands for, and angle A is 120. You have it in this form. So 36 plus 64 minus, if you multiply 2 by 6 by 8, you have 96. Cosine of 120 degrees is minus 0.5. That simplifies to this, and you have 148. To get A, the distance of the boat from the starting point, you take the square root of 148, and that is 12.1655. To the nearest kilometers, you have 12 kilometers. Roman figure 2, from the diagram, the bearing of the boat from the starting point is 040 degrees plus theta. Theta is needed if you visit the diagram and is obtained using sine rule. The side facing theta is known, the angle of 120 degrees, the angle of 120 degrees, the side to it is this 12. So the sine rule is stated in this form. If you make sine theta the subject, you have this result: 8 times sine 120 degrees, you have this result, divide by 12, and that is 0.5773525. To get theta, you need to take the inverse of sine of this value, and that gives 35.2643 degrees. The required bearing is 040 degrees plus 35.2643 degrees. If you add, you get this result. To the nearest degree, you have 0.75 degrees. In bearing calculations, we always use 3-digit bearing. Hence, the addition of the 0 before 75 and other angles that is affected.